prior to jumping into the announcement, it's vital to understand the meaning of what we're examining. The enormous Hadron Collider, LHC, built by CERN, stands as a fantastic accomplishment in science. Spanning 17 miles, this mind-boggling network of superconducting magnets is not only the largest but also the most powerful particle collider on Earth. It is an exceptional representation of human creativity and scientific achievement. Notably, the LHC is so powerful that it has the capacity to recreate conditions similar to those present at the birth of the universe. Yet, as we explore the vastness of the cosmos, could this machine, which aims to unlock the secrets of existence, accidentally expose us to more dangerous consequences? The legacy of CERN and the role of the LHC. Founded in 1954, CERN is one of the world's most prestigious scientific research institutions, comprising 23 member nations and a vast community of researchers. It serves as a hub for collaboration and innovation. While the LHC is its flagship project, it is just one part of a vast array of particle accelerators and experiments. Think of it as a track, not for cars or horses, but for subatomic particles racing against each other in a trial of speed, precision, and the very nature of spacetime itself. At the LHC, protons are accelerated to nearly the speed of light, replicating the energy levels present at the moment of the Big Bang. The resulting collisions generate temperatures far hotter than the Sun's core. A network of magnets directs the protons on their path, while advanced cooling systems maintain the temperature of these magnets at levels colder than outer space. Collisions occur at 4 specific points around the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, capture data. Each detector serves a unique purpose, offering different perspectives on the aftermath of these collisions. Together, they function like massive cameras, recording the results while scientists sift through the debris to uncover elusive particles such as the Higgs boson, often called the God particle. These discoveries help piece together the fundamental building blocks of our universe. By focusing on the subatomic realm, scientists seek insights into the very nature of reality. However, every new discovery only raises more questions, pushing the boundaries of science. A blessing or a curse? The LHC is not just an instrument. It represents humanity's relentless curiosity and insatiable thirst for knowledge. It embodies our desire to understand the forces that govern existence. However, as we push the boundaries of the unknown, we must confront the ethical and existential challenges that accompany such a pursuit. What dangers could arise from delving too deep into the unknown? Could our quest for knowledge inadvertently unleash forces beyond our control? At CERN, where the limits of human understanding are constantly tested, a disturbing realization has emerged, one that has sent shivers down the spines of even the most seasoned scientists. The concerns of experts. Brian Cox, a former CERN researcher and a respected voice in the field of particle physics, recently made a startling statement that has both fascinated and frightened people worldwide. According to Cox, the LHC's purpose is to simulate a miniature Big Bang, a small-scale version of the very event that birthed our universe. Cox further elaborated on the significance of this goal, emphasizing the immense potential of the LHC to make groundbreaking discoveries, such as unlocking the mysteries of dark matter, a mysterious substance that constitutes a large portion of the universe. The possibility of harnessing the fundamental forces of the universe is undoubtedly captivating, but it comes with inherent risks. The miniature Big Bang is not merely a theoretical concept. It is a real phenomenon occurring inside the LHC. The collider replicates conditions of extreme heat, pressure, and energy, mirroring those present at the dawn of existence itself. With such immense power comes great responsibility. What if something goes wrong? A chilling historical incident. This is not a new concern. In 1978, Russian physicist Anatoly Bugorsky experienced an incident that dramatically altered his life. While working with a UB-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction caused his head to accidentally cross the path of a proton beam. The beam, traveling at nearly the speed of light, pierced his skull, entering through the back of his head and exiting through his nose. Although Bugorsky saw a flash of light brighter than 1,000 suns, he remained conscious and even walked to get medical help. The aftermath was both fascinating and terrifying. He lost hearing in one ear, suffered partial facial paralysis, yet his cognitive functions remained intact. Despite the severity of his injury, he continued his scientific work. Bugorsky's experience serves as a stark reminder of the power and potential dangers of particle accelerators. The risk of a black hole. The risks associated with a particle collider like the LHC are not to be taken lightly. Some scientists have raised concerns about unforeseen reactions that could alter the very fabric of existence. One of the most controversial fears is the possibility of creating a black hole inside the collider. Black holes are regions of space where gravity is so intense that nothing, not even light, can escape. They are mysterious, cataclysmic forces lurking at the edges of the universe. The idea that the LHC could create even a tiny black hole is both astonishing and terrifying. Could such a black hole grow out of control, devouring the Earth from the inside out? CERN scientists have reassured the public that any black hole formed would be highly unstable and would vanish almost instantly. However, the remote possibility of such an event has sparked widespread debate and concern. The fabric of space-time. To understand how the LHC could potentially create a black hole, we must first consider the fundamental mechanics of a particle accelerator. When protons collide at nearly the speed of light, the energy produced is so intense that it can distort the fabric of spacetime itself. Imagine a trampoline stretched tightly, and then a heavy object is dropped onto it. The fabric bends, and if the object is heavy enough, it could create a deep depression that pulls everything around it inward. This simplified analogy gives a glimpse into how the LHC might affect spacetime at a quantum level. Theoretical physics and the LHC. At the quantum scale, where the laws of physics appear strange and unpredictable, some theories suggest the existence of extra dimensions beyond the familiar 3 dimensions of space and 1 of time. If these extra dimensions exist, the LHC could potentially tap into them, possibly creating a gravitational well that leads to a tiny black hole. This possibility has attracted the attention of renowned physicists, including the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at extremely high energies, triggering catastrophic consequences, such as vacuum decay. Similarly, astrophysicist Sir Martin Rees has explored the potential dangers of particle accelerators, emphasizing the devastating possibilities if something goes wrong. The unknown risks of high-energy physics. While scientists at CERN assure the public that the LHC's experiments are safe, the nature of high-energy physics demands caution. The potential for unexpected consequences, such as vacuum decay, strange matter formation, or the destabilization of the Higgs field, cannot be entirely ruled out. One of the most alarming scenarios is the possibility of vacuum decay. In simple terms, our universe exists in what physicists call a false vacuum, a stable but not ultimate state of energy. If an experiment at the LHC were to create a perturbation strong enough, it could theoretically trigger a phase transition that would shift our universe into a true vacuum state. This event, sometimes referred to as a vacuum catastrophe, would propagate at the speed of light, wiping out existence as we know it. While this sounds like the plot of a science fiction movie, even prominent physicists, including Stephen Hawking, have discussed the theoretical plausibility of such an event. Hawking once warned that the Higgs boson at high energy levels could become unstable, leading to a catastrophic collapse of the universe. However, other experts argue that the energy levels produced at the LHC are still far below those naturally occurring in cosmic ray collisions in space. If the universe has endured billions of years of these high-energy events without catastrophe, the likelihood of a particle accelerator triggering such an event is infinitesimally small. Are we playing with forces beyond our control? Beyond the scientific dangers, there are philosophical and ethical dilemmas surrounding the LHC's experiments. Are we tampering with forces we do not yet understand? Could our relentless pursuit of knowledge backfire in ways we cannot predict? What happens if we uncover something that fundamentally challenges our understanding of reality? Some scientists and theorists speculate that our very observation of these subatomic interactions could have implications beyond physics, delving into the realm of metaphysics and consciousness. If reality is shaped by the interactions of fundamental particles, what does that mean for our own existence and perception of reality? the future of the LHC and beyond. Despite these concerns, CERN is not slowing down. In fact, there are plans for even more powerful particle accelerators in the future. The proposed Future Circular Collider (FCC), expected to be 100 kilometers in circumference, would be nearly 4 times the size of the LHC and capable of even higher energy levels. If the LHC has already pushed the boundaries of physics, what new discoveries or dangers await us with an even more powerful collider? Many argue that the LHC's contributions to science far outweigh the risks. The collider has already led to groundbreaking discoveries, such as the confirmation of the Higgs boson, and it continues to deepen our understanding of dark matter, antimatter, and quantum mechanics. However, as history has shown, scientific breakthroughs often come with unintended consequences. The development of nuclear physics led to both nuclear power and the atomic bomb. Could our exploration of the subatomic realm lead to discoveries with equally profound, yet unpredictable, implications? Conclusion: the thin line between genius and recklessness. The Large Hadron Collider represents humanity's greatest intellectual achievements, but also one of its greatest gambles. As we continue to unlock the mysteries of the universe, we must ask ourselves, are we prepared for the answers we might find? Can we ensure that our pursuit of knowledge does not lead to unintended destruction? As science continues to push the frontiers of the unknown, one thing is certain. The LHC is not just a machine, it is a gateway to the deepest truths of our existence. Yet, as history reminds us, every great discovery comes with risks. Whether those risks are scientific, existential, or even cosmic in scale, only time will tell if our search for the fundamental nature of reality will lead to enlightenment or catastrophe. Precariousness. He recognized that while the probability of such an occasion happening was low, even a little opportunity justified cautious thought. A lot is on the line, and the edge for mistake is razor-thin. Specialists at CERN have conducted extensive simulations and analyses, taking precautions to ensure the security of their trials. Brian Cox himself has acknowledged the concerns surrounding the LHC, emphasizing that there are strict safety measures in place. These measures include rigorous reviews and protocols to ensure that the collider's operations are conducted with extreme attention to detail. According to Cox, the energies involved in LHC tests are significantly lower than those that naturally occur on Earth. The chances of creating a stable black hole are astronomically low. Even if one were to form, it would be so small and unstable that it would quickly dissipate, releasing an explosion of energy as predicted by Hawking's theory of radiation. Some have speculated that the LHC's experiments could open a doorway to another universe or dimension. While this idea is largely dismissed by mainstream scientists, it has captured the imagination of many, fueling myths and rumors. What lies beyond our universe? Could we accidentally unleash forces or entities we do not understand? The concept of opening a gateway to hell has even been sensationalized in the media, adding to the uncertainty surrounding these investigations. The origin of these ideas. But where did this idea come from? And what does it mean in the context of scientific exploration? The concept of parallel dimensions is not new. String theory, a leading candidate for a unified theory of everything, suggests that there may be more than the 4 dimensions we experience, 3 of space and 1 of time. These extra dimensions may be hidden from our senses but could, in theory, be accessed under extreme conditions. Imagine the LHC as a key unlocking doors to realms that have remained hidden since the dawn of humanity. When protons collide at energies previously unheard of on Earth, they could create ripples that test these hidden dimensions. While this idea remains speculative, it highlights the allure of the unknown. The possibility of discovering other dimensions continues to captivate the public, even though mainstream scientists remain unconvinced that the LHC will open a portal to another universe, or to hell itself. Nevertheless, the idea of the LHC being a massive key unlocking new realities continues to fascinate many. Should we be worried? Should we be worried about the risks associated with the LHC? It's easy to be swept up in sensational headlines and fears of a cosmic disaster. However, scientists at CERN are well aware of the potential risks. They have taken extensive precautions to ensure the safety of their experiments, continuously monitoring and assessing their work with the utmost diligence. The potential benefits of their research, such as unlocking the secrets of dark matter, discovering new particles, and expanding our understanding of the universe, are truly remarkable. While these achievements represent a significant leap forward in human knowledge, they also come with inherent risks, as is the case with all great scientific advancements. The LHC's experiments raise important ethical questions. Could the creation of exotic particles or the study of high-energy environments trigger unforeseen consequences for our planet or the very fabric of reality? These are questions that cannot be taken lightly. They require thoughtful consideration of the broader implications of science as a whole. The LHC. A testament to human ingenuity. The Large Hadron Collider stands as a testament to human ingenuity and curiosity. It has already made groundbreaking discoveries in particle physics, shedding light on the mysteries of the universe. However, as we venture into these unknown territories, we must remain vigilant and mindful of the risks involved. The pursuit of knowledge is one of humanity's most ambitious endeavors, but it is not without its challenges. The LHC represents the cutting edge of scientific exploration, where theory meets experimentation and where the very foundations of our understanding of the universe are being tested. The journey of discovery is rarely without risk, and the LHC is no exception. It pushes the boundaries of physics, striving to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. Yet, as we continue to explore these frontiers, we must acknowledge the profound ethical and existential questions that arise from manipulating the forces of the universe. The risks of unintended consequences, whether for our planet or for the very fabric of space-time itself, remain a challenge that requires careful reflection. The relentless pursuit of knowledge. Nonetheless, the pursuit of knowledge remains one of humanity's most noble endeavors. The LHC's experiments, while risky, offer a glimpse into the vast, mysterious realms of science awaiting discovery. As we stand on the brink of new revelations, the journey to unlock the universe's secrets requires both ambition and caution. The LHC represents not only the pinnacle of human technological achievement but also a powerful tool that has the potential to reshape our understanding of everything, from the smallest particles to the most grandiose cosmic phenomena. With each breakthrough comes a wave of new questions, opening new avenues of thought and exploration. The journey of scientific discovery, though fraught with uncertainty, holds the promise of findings that could redefine our perception of the universe, our place in it, and the very laws that govern it. The intersection of theory and reality. One of the most profound aspects of the LHC's experiments lies in the intersection of theory and reality. For decades, physicists have grappled with the forces that shape the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The goal has always been to unify these forces under a single framework, a theory of everything. The LHC has been instrumental in providing insights and experimental evidence that bring us closer to this elusive goal. Its work doesn't just advance our understanding of particle physics, it holds the key to uncovering the fundamental truths of existence itself. The ethical dilemmas associated with such experiments are significant. The pursuit of knowledge has always carried risks, but when those risks involve altering the very fabric of reality, the stakes become even higher. Could an experiment at the LHC accidentally trigger a phenomenon we do not yet understand, leading to consequences that are difficult, if not impossible, to predict? This is a question that scientists, philosophers, and ethicists continue to contemplate. The responsibility of scientific advancement. As we venture into these realms, we must consider the responsibility that comes with wielding such immense power. Yet, despite the potential dangers, few would argue that the pursuit of scientific progress is not worth the risk. The rewards, new technologies, medical breakthroughs, and an expanded understanding of the universe, are immense. The discoveries made by the LHC so far have already transformed the scientific landscape. From the identification of the Higgs boson to advancements in our understanding of dark matter, these achievements have far-reaching implications, not just for physics but for numerous other fields that rely on this foundation. No experiment is entirely risk-free, and the LHC, grand and powerful as it may be, is no exception. Yet, with each risk comes the potential for groundbreaking discoveries. The LHC stands as a symbol of humanity's relentless pursuit of knowledge, a mission to answer questions that have puzzled us for centuries. In the end, it is this curiosity that drives us forward, the desire to understand the universe, to peer into the depths of reality, and to uncover the forces that govern everything from the tiniest particles to the largest galaxies. The LHC may carry risks, but it also represents the pinnacle of human achievement in particle physics. It is a tool that allows us to explore the deepest questions of existence, challenge the very laws of nature, and seek answers to the mysteries that have eluded us for centuries. Whether the LHC will ultimately lead to the discovery of new dimensions, open gateways to parallel universes, or trigger unforeseen phenomena, we cannot yet say for certain. What we do know is that it remains one of the most powerful scientific instruments ever created, capable of unveiling secrets about the universe that were once thought to be beyond our reach. The potential for discovery is limitless, and as we venture further into the unknown, we are reminded that science is a journey, one that requires both boldness and responsibility.